Hello everyone, and welcome to our seminar, Reliable Testing Solutions for Catheters, Guidewires, Tubing and Connectors, according to ISO 80369 today. My name is David Phillips, and I'm responsible for market intelligence in the ZwickRoell Group. The COVID-19 pandemic has resulted in a dramatic increase in intensive care treatment of infected patients, and in turn, this has led to an enormous shortage of respirators and its components such as tubing. Other products such as catheters are also required for treating patients. In times where a lot of patients are in hospital and require care, it is crucial that no failures occur. That is why connectors have an important role to play. At ZwickRoell, we have offered testing systems for respirator components, catheters and connectors for many years now, and can see steadily changing requirements. Today, in this webinar, we want to give you an overview about the current testing requirements and our solution for these products. But before I start, I want to mention that we'll be taking questions at the end of the webinar. So please submit questions that you have anytime during the webinar using the Q&A function, which you will find in the GoTo Webinar panel on the right side of your screen. We'll answer as many as possible at the end of the webinar. However, any that we are not able to cover will be individually answered by email. Now, I would like to introduce two of my colleagues today. Expert colleagues for today's webinar are Mr. Peter Schmidt, Product Manager at MedPharm, and also Alexander Rank, Senior Sales Engineer and Product Manager. They will share their experience, their insights and knowledge about the mentioned medical products. So, first of all to Peter. Peter, welcome to the webinar today. And as I said in the introduction, we're seeing a growing need and demand for catheters. Could you tell us first, please, what is a catheter and also what is a guide wire?
Yeah, David, thank you very much for your introduction and also a warm welcome from my side to the audience. Coming back to the question, what is a catheter? The most simplest form of a catheter is a thin tube, usually made of soft plastic, that can be inserted into the human body. A complex one instead can contain electrical sensing and application facility or are even equipped with a 3D optical system. Guide wires are, for example, needed for guiding and placing the catheters to the correct position throughout the vessel system of the body. This happens mostly via X-ray control.
Okay, so what kind of catheters exist and what are they typically used for?
David, there is a large variety of catheters available on the market. It can be differentiated in diagnostic and therapeutic catheters in different medical areas. You can find both types, so the diagnostic and the therapeutic ones, for example, in the cardiac and neurovascular area. Typical examples for diagnostic catheters are for measuring electrical signals of the conduction system in the heart or 3D imaging catheters. Catheters for therapy purposes are, for example, used for placing stents with a balloon catheter or even for correcting the electrical pathway from arrhythmias with an ablation catheter. Furthermore, there are single-use and long-term catheters available. Both these types can typically be found in the urology and home care area. A typical type for that is a bladder catheter. A bladder catheter is used to drain collected urine from the bladder. It is always necessary when a patient is no longer able to urinate independently, for example, due to a narrowing of the urinary tract or a nerve dysfunction or even paraplegia. Just as some representing examples.
Thank you for that interesting overview, Peter. Could you please tell us something about which standards are relevant for these products, and also what do the standards require regarding materials testing?
Yeah, David, there is actually a wide range of standards for different types of catheters and interventional accessories available, reaching from ISO to ASTM standards. The applicability is depending on the region. Different types of catheters related to different places of operation in the body with different purposes of use, as mentioned already in diagnosis or for therapy. These are covered by these standards. Places of operation are, for example, the heart, the blood vessel system, the brain, the bladder, rectum, lung, or even other organs as well.
Okay, thank you. Next, can you please give us an overview of typical testing systems and maybe highlight their specialities for catheter testing?
Yeah, David, since catheter applications are standing interventions, that means the operator is standing at the treatment table, ZwickRoell offers, on the one hand side, modular, horizontal, dual column testing machines in order to be able to depict the examination situation as accurate as possible. On the other hand, especially for urological catheters, for example, Foley catheter, it is necessary to measure the lubricity of these catheters. For this requirement, ZwickRoell offers also a modular system with a heatable, height-adjustable medium bath in a vertical single column setup.
Okay, this is interesting. And I particularly like the concept of a horizontal machine that can simulate the real situation. I think we'd like to learn more about that. Could you please give us some more details? For example, what components are required, and what options are possible? And can you show us what this system looks like?
Yeah, David, you're right. It's indeed interesting. We offer that unique system since years, and we have it further developed based on the feedback given by our customers. Look, the picture on the left side shows a typical scenario where a doctor places the catheter in the cath lab under X-ray control. Step by step, he pushes the guide wire for the catheter through the blood vessel system to the destination. Several curves of different radii and branches determine the pushability and trackability of the catheter. The pictures on the right-hand side show the ZwickRoell system solutions. You see a horizontal testing system with flexible placement of anatomy models illustrates the examination process one-to-one. The heatable media bath, which can be expanded with pulsatile blood circulation simulation, enables a simulation of the intervention close to the examination, for example, in a hospital. The specimen holders and tools are, of course, submersible. The testing system can be equipped with heatable water bath in order to simulate patient-specific body conditions. With these systems, for example, the trackability, pushability, and crossability force, also flexibility or kink force and insertion force can be measured. Push efficiency is also possible with an additional load cell.
Thanks. That's a good overview and a good explanation of the process. Is there any way you can show us how this system actually works in practice?
Yeah, David, for a better understanding how such a test could look like, please lean back and let me show you a short video of it.
Thank you.
So the next video can also be found on our YouTube channel, and this is how it looks like on the front view, the horizontal testing machine. You can see how the operator is using the system. There is a possibility for manually open and closing the grips. Here on that view, you see the anatomy model and the gripping procedure with the submersible grip. You see the guide wire pushed forward into the model, and it's retracking and repushing again until it reached the final destination. As said before, there are different models available. You can either use 3D printed models or the ASTM aligned models that are also available from ZwickRoell. The withdrawal you can see in the next section is also as the doctor is doing it on site on the table. He's pushing back the catheter step by step. Here you see the biggest, the most important as big as possible, the camera view and the documentation of the test itself. The camera is also submersible. On that point, you can see how easy it is to load and clean the pegboards or breadboards. And at the very end, you can see the summary of the most important points from this machine and testing setup in a horizontal way. As said before,
thank you.
We have it in the YouTube channel available for you as often as you want.
Right. Thank you, Peter. That video is really helpful, and I'm sure our participants can now visualize how this testing helps product developers and users to simulate different conditions and also to improve their practical skills. Earlier, I think you mentioned that there are also vertically orientated testing solutions. Could you please give us some more insight into that kind of testing?
Yeah, David. So the next slide shows a typical example for a vertical setup, the lubricity testing of urological catheters. Just imagine you have to insert a catheter into your own body. Any friction would be uncomfortable for you. So the lubricity has to be as high as possible. And this is what we are testing. How high is the lubricity? The system itself is equipped with a heating unit and extensometers as well. I also want to emphasize that the gripping unit is equipped with dead weights, which are key for reproducible and reliable test results. The system can easily be adapted to different catheter types with exchangeable jaw faces that show individual gripping capabilities. That makes the system flexible and reproducible. Cyclic loading of the catheter also simulates the insertion process.
Okay. I'd like to ask you to explain, please, which companies require testing on catheters, either with a horizontal or with a vertical testing machine?
The companies requiring catheter testing machines are manufacturers for different types of catheters and its accessories. Furthermore, we see growing interest for our horizontal systems in companies that develop and manufacture heart valve applicators for the implantation of heart valve replacements. TAVI is an example that has been in the press for a long time. And there are also testing labs for catheter systems, so-called service provider for catheter testing that require our testing systems.
Okay, I got it. Is there any difference in testing between R&D, for example, and production or quality assurance? And if so, can you tell us a little bit more about that?
Yeah, definitely. So in R&D and design verification, they are much closer to real-life requirements. That means they do simulations of the intervention that are performed by the doctor in a, let's say, close to investigation setting. This can be implemented very good with our modular horizontal testing machines, either in a dry setup or with human body conditions with submersible components in a media bath, heating and circulatory pump systems. In production, in contrast to that, the tests are much simpler and are mainly tensile and/or compression tests.
Okay, thank you, Peter. I think you managed to give our participants today a valuable and really interesting overview. Now I'd like to move the conversation towards a different topic, and that is connectors. Alex, first of all, can I welcome you to the webinar today? And also, can I turn to you and for example, I can imagine that especially in a stressful situation in a hospital and in the care system in general, it's highly important that there's a fail-safe design when administering drugs to patients. I also learned that there's a new testing standard called ISO 8369, which is now applicable. So before we get into the details, can you give us some more background information on this topic?
David, for sure. But let me first say a warm welcome to the audience. It is a pleasure to share my insights with you. The small bore system is a standardized connection system for the combined use of syringes and infusion sets in the medical field. It is used, among other things, for cannulas, syringes, and catheters. Such as connectors have a long history. Already in the 1950s, there was a patented design of a connectors. In 1986, the standards ISO 594 with the sections 1 and 2 were developed, which were valid until the end of 2019. Now, ISO 594 has been replaced by ISO 8369, at least.
Okay, so this is not really a new story. Those standards you mentioned have been in place for more than 30 years. So why is it necessary do you think, after this length of time to replace ISO 594 with ISO 8369?
So, David, the point is that the problem with the small bore system is that multiple connections between medical devices and tubing are common in patient care. Connecting the wrong system together has caused patients injuries and real death cases. That is why in 2007, an international group formed to work on the ISO 8369 standards. They reviewed designs, tested misconnections, and discussed requirements.
Thank you. Okay, so now I can understand why the new standard was introduced. Alex, could you give us some more insight into the ISO 8369 standard itself, please?
The ISO 8369 standards is valid for different application types. So you can see all of these in the current slide. The general requirements are covered in section 1, which explains if medical components can be fitted together or not. Section 20 describes all of the common test methods. For example, the mechanical test sequences, for example, resistance against overriding. The section 2 till 7 describe the detailed mechanical and leakage tests for the various applications. So let us take more detailed look into some of these applications.
Yes, I agree. I'm very interested in the mechanical testing of these devices. So what kind of solutions do we offer?
So if we are taking about the most common one, the ISO 8369 20, it is important to know that each specimen has to be assembled according to the standard with a suitable reference connector before the test sequence start. In the past, these both test sequences have to previously been carried out separately. The big advantage of the ZwickRoell solution is now that the workflow can combine these steps, assembly and testing in one procedure. I already heard from our customers that they save time and reduce failures by repeated handling of samples and therefore money. The Zwicki line with a superimposed torsion drive, which can handle the assembly process of the connectors. An integrated air pressure control system is able to handle up to 330 kilopascal and also a negative pressure down to minus 88 kilopascal. Everything is totally integrated in our system. After starting the process, there is nothing to do for the operator. The test machine controls all process parameters, including the integrated air pressure system. A calibrated pressure sensor is connected to our system configurator, and this enables us to achieve the requirements of the FDA 21 CFR Part 11. ZwickRoell has already delivered many systems over the world, and we are able to supply the necessary clamping devices and reference connectors.
Okay, I can imagine that there are a wide range of geometries on these medical devices used with these small bore connectors. Is that correct?
Absolutely correct, David. On the upper right side of the slide, you see there's a clamping device for vials and syringes of different geometries. Individual parts can be changed, for example, by different jaws. For asymmetric medical devices that you are being in the test axis, we can generate a customized fixture using down on 3D printer. For example, we integrate a customized medical filter component combined with a small bore connector, which you can see it in the lower right picture.
Thank you, Alex. I think you made a very important point, which I would like to confirm back with you. You mentioned that your testing system not only carries out the mechanical testing, but the machine can also assemble the product prior to the testing and then automatically carry out the test itself. This will surely allow laboratories to save a lot of time and money, whilst at the same time achieving better results. First of all, is this true? And if it's true, is this a unique solution in the market, do you think?
As far as I know, yes, that's it.
Okay, that's great. Thank you, Alex. That's good news. I mean, throughout this discussion so far, we've talked a lot about the mechanical part of the testing, but I know that nowadays software always plays a very important part, and I also believe that sophisticated testing software which controls the complete testing machine is essential if laboratories want to achieve reliable test results. Peter, if I could turn back to you for a moment, how is ZwickRoell approaching this topic? And can you share, I mean, yeah, this is a very detailed topic, I know, but can you share at least some of the details with us today?
All right, David. So absolutely, you're right. This software is paramount. And today, without software, testing would not be possible at all, especially for handling all the generated data and doing data analysis. Our testing software, testXpert 3, offers a lot of features to guide the user, but also to protect the test data and test configurations. So let me briefly describe the most relevant ones in my eyes. First of all, the pre-configured standard test programs. That means there is no need for customers to go into the standards, checking the detailed requirements and entering them during the configuration of the test. We have already done that for the customers. The second one, the system configuration builder. First of all, this protects the sensors from being damaged. However, this is also very important when testing different products with different requirements regarding the configuration of the machine. For each test, the configuration only has to be entered and saved once. Then it can be reloaded automatically with the test sequence. And as an added value, a barcode scanner can be used to avoid errors in data entry. And this helps to improve the reliability of test results. Let me come to the third point. It's the user management. For users who have to meet the 21 CFR Part 11 and EU GMP Annex 11, we offer a user management system which allows freely configurable users and user groups that can be automatically tracked and logged in the machine control system. There is a white paper from us available which explains how this works, so please contact us for more details. 21 CFR Part 11 and EU GMP Annex 11 is dedicated to electronic records and electronic signatures as an explanation. And the audit trails of the system contains the when, the who, what, why, and who is responsible. And customers can also benefit the Windows LDAP system. By the way, David, we have more than 30,000 installations of testXpert 3 running worldwide. What is also important is that testXpert is a single control software for all applications and industries. That means less training, support, intuitive operation, easy changing of operators is possible with our software.
Thank you, Peter, and thank you for your experience and advice and insights today. Also, I'd like to extend my thanks to Alex as well for sharing his experience and expertise. I'd like to move now towards the question and answer session, and we'll take a look at the questions that have been entered into the webinar Q&A session. Let me just try to find one that I could ask you. Maybe Peter first. I think this one is a good one. Peter, it says here you mentioned a transcatheter valve replacement. Do you actually have experience with that?
Yeah, David, let me try to give you that answer in that way. So, yeah, we had already a couple of projects with market-leading companies for testing the applicators in our horizontal testing machines. So the applicators are for doing the implantation of the new heart valve into the heart, and we solved it with customized fixtures and software that is also adapted to the special solution.
Okay, thank you. Next question is, I'm a producer of stent-loaded balloon catheters. Do you offer tests for, I think it's securement of stent on balloon. I guess this is Peter as well, is it?
Yeah, it's for me, David. So the answer is short. Yeah, we developed already toolings to measure the force to remove the stent from the balloon.
Okay, thank you. Third question, the catheter testing machine you mentioned has a modular concept. Can you explain, please?
Yeah, so there are different setups available and different settings available for horizontal testing machines. So on the one hand side, you can use it in a dry version. So there's just the pegboard or the breadboard with a liquid drain without any bath, heating and pumping system. And the second setup is the testing with submersible equipment. And we have a stainless steel media bath, an optional heating system, and submersible grips and cameras. So different anatomy models are available for that as well.
Okay, thank you. I'm going to try maybe to find one or two more, and I try to stick with you, Peter, for the moment. Here's one which says, R&D requires connectivity to third-party sensors for the design verification. Do you have a solution for that?
Yeah, just recently we had this requirement from one of our customers, and so they use the machine just for design verification purposes with enhanced connectivity possibilities, and they wanted to connect flow and torque sensors to our system, which is possible.
Okay, I found two actually, so I think I'm going to try to get two questions more for you before I move to some questions for Alex. Peter, are there any 3D models available?
David, there are ASTM models for whole leg length and the ascending aortic scenario available, and used for preconditioning before tensile tests. So most customers build their own models, and they have a kind of difference available that they can easily adapt on our pegboards. And up to beating hearts, we had also a project for simulating the placement of heart valves. So this was a very realistic project with a customer.
Okay, great. Sounds interesting. One final question then for you, Peter. It's how can you test the lubricity under wet conditions?
David, we saw in one of the slides there is this vertical setup where we have this adjustable water bath with heating and the grips with a defined exchangeable surface to guarantee some friction behavior for each test. This was the scenario also with the dead weights, and where we can also do some cycling loading for testing the lubricity tests.
Thank you, Peter. Alex, I think I found at least one, maybe two questions for you. First question is, our products are made of glass. How to prevent leakage?
Oh, David, this is a good question. You can imagine that a leak test of glass device in combination with a metallic connector will not work. But our solution includes special plastic connectors, which suits to the ISO 8369 requirements, so that we are able to test both glass and plastic.
Thank you. Okay.
Yeah.
I think interesting. Yeah, thank you. I did find one more. Here's one which says, I heard that the ISO 8369 is already under revision.
Yeah, so that's right. So ZwickRoell is a member of different standardization committees, and we see that the new revision with the updated tolerances of the reference connectors are a good solution. But the actual standard is very restrictive and ask for reference connectors with a very small tolerances, which can be produced but not measured. And our testing setup can easily used with the old and already with the new referent connector. This is our feature that we have already, the additional feature.
Okay. Thank you, Alex. Okay, so what I'd like to do now, if possible, is to try to summarize some of the main points which I took from the webinar today, and I hope which will be useful to our participants as well. So just to bring these points once again, I thought the most important regarding catheter testing systems for me was that the way the full-length sort of horizontal system simulates the precise environment, the real world, let's say, and the way in which the doctor actually works. And in addition to that, using the horizontal machine, the whole process can be totally automated, so that the reproducibility of a test can be as high as it's possible to get. If I look at the connector systems, I thought the most important part for me was that the ZwickRoell solution seems to be unique in the market, and that means the system not only carries out the mechanical test, but it also assembles the different components prior to the test. So the real benefit of this system is the whole process is done in one complete say process or cycle, and must save a lot of time for laboratories and a lot of time for operators having to assemble and disassemble different things. So I thought that was good. And I would say in summary that for anybody that found this webinar interesting and maybe they would like to read more information going forward, you can find a lot more information about the testing of catheters, small bore connectors, for example, on our website at ZwickRoell.com, and also our YouTube and Twitter channels. We're always interested to hear about your individual test applications at ZwickRoell and your challenges that you face on a daily basis. So please don't hesitate to get in touch with us to discuss those applications. You can either do that directly or just contact your local sales office in your country. And don't also forget that we have a fully equipped application test laboratory in our headquarters in Germany, and this is available for you to carry out mechanical testing in real, in a real life situation. And we can also discuss and help you to find interesting solutions to your testing challenges. And finally, of course, our global service organization is always on hand to support you wherever and whenever you need that, anywhere around the world. So I'd like to finish by saying thanks once again to Peter Schmidt, to Alex van der Rank for sharing their knowledge and insights today. Thank you to all the participants for spending the time and listening to us and participating and asking questions. We really appreciate it. And I'd like to finish by saying stay safe, and we will see you in the next seminar.